All right, for this video, we're going to jump to 9.2, and we're going to work with arithmetic sequences. And this is where we zero in on this type of sequence. The first section was kind of a mixed bag. We work with all different types of patterns and sequences. This arithmetic sequence, I think this is one of the easiest or easier ones, type of patterns to look at. These are the ones where I kind of talked in class. It's kind of linear. And an arithmetic sequence it's kind of like the slope. You always go up by the same number or down by the same number. This is where you just add or subtract to get the next number in the sequence. All right. Okay. And we're going to relate this a lot to slope. The first one, we're going to come up with a formula, and we did this in class yesterday, coming up with formulas. These are the easier ones. Now, if we want to come up with formulas, we're always going to put a sub n, because that's just the form we put it in. Remember, a represents the numbered term in the sequence. Well, I see right away for number 1, it always goes up by 4. Now, this is what's going to be new. I'm going to put this here. D equals, look at this here. D equals 4. And what D means, that's the common difference. So since we always add 4, we're going to make it positive 4 as the common difference. This common difference, this basically is kind of like your slope. Kind of like if if you graph the line, you'd always go up 4 to the right one, up 4 to the right one. Well, this you always add 4. So I'm going to have 4n. Kind of like how you have 4x when you graph a line. And then you have to add something to it. Because if I plugged in n equals 1 for this, 4 times 1 is 4, but my first term is 7, not 4. This is where you do that little trick, and hopefully I think I did do it in class the last couple of days. If you go the other way, now this only works for an arithmetic sequence. If you go the other way, you would actually take away 4, you would get 3. This kind of represents like your y-intercept. That's going to be the number that you add. And this is your equation for it. So this really is like coming up with an equation for a line and slope intercept form, and you can check it. For this 7, well, n equals 1. So if you plugged 1 in here, 4 times 1 is 4, plus 3 gives me that 7. For the 11, that's the second term in the sequence. So n equals 2 for the formula. If you plug it in, you have 4 times 2 is 8, 8 plus 3 is 11, and then you see that it pretty much works. Okay? Now, it's real easy to relate this to slope-intercept form when you have the entire sequence, but a lot of the problems that we're going to do in this section, we're not going to have the entire sequence. We might have maybe the second term and the 9th term. Okay? So in order to kind of come up with the sequence and come up with other numbers in the sequence, we're going to derive another formula here for any term of an arithmetic sequence. So let's use number 1. I'm not going to do number 2. We'll probably do that in class tomorrow. I'm going to do number 1 and kind of look at it, kind of pick it apart, and come up with a formula for an arithmetic sequence so that we can use it for any type of problem. Okay, I know for this warm-up here, number 1, the first term was 7. And I know the common difference is 4, so I keep adding 4. So to get the second term, I can start with the 7 and I add 4 to it. Now I'm going to put here 4 times 1. You might say, well, that's kind of stupid. Why are you doing that? That's kind of redundant. Well, I'm using it to kind of come up with the formula. Then for a sub 3, I know if I keep adding 4 to it, I'm still going to start with this 7. And if I add 4 to it, well, it'll be like adding 8 to the 7, or it's like saying 4 times 2. Right? And if I did that, 4 times 2 is 8. 8 plus 7 is 15. That's the third term. And then for the fourth term, if I start with the first, I have 7 plus, and if I add another 4 to it, then it's 4 times 3. Okay, again, if I do this, 4 times 3 is 12. 12 plus 7 gives me 19, and there it is. That's the fourth term. Now, why did I do all this? Why did I always start with 7? Because this kind of gives us our formula for the nth term of an arithmetic sequence. Here is, I'll put this in a different color. For all of these, I started with the first term. So the first term was 7. So when I come up with it, I'm going to put a sub 1 plus. Now this 4, there was always a 4 in it. This was D, right? When I came up with D. So I'm going to have D times, here's the connection right here. These numbers, 1, 2, and 3, like 3, that's 1 less than this 4. 2 is 1 less than the 3, which means the third term we want to find. 1 is 1 less than the second term we want to find. So if I'm saying this is n, then here it's got to be 1 less than it. So this is just n minus 1. So this will give us the equation, which is kind of like in slope-intercept form, and it'll really be beneficial for us when we don't have all the numbers in the sequence. And you'll see as we go along. Now this right here, variations of the formula, I'm just going to put this right here. This is going to lead into variations of the formula, which I'm going to go over in class tomorrow. When you add this subscript and this, whatever this number turns out being, when you add these, I'm just going to put 1 plus n minus 1. You can see the 1's cancel, and it always equals n, which is whatever term in the sequence that you want to find. Okay? You might be saying, well, why are we doing that? We're gonna do this in class tomorrow, but not on this video yet. All right, so let's look at some of these here. Let's look at number 1. Okay, it has find a formula for the nth term. Now, this prompt one, you could probably come up with it a couple ways. I'm going to use what I just came up with using this formula. Okay, so it has a sub 1 equals 2. Find a formula for the nth term. So I'm going to put a sub n equals. When I use this a sub 1 is 2, and then plus, I know d is 3, so I'm just going to plug 3 in. So I plug 3 in, and then I'm going to leave the n minus 1 in, because n is going to be a part of the formula. And then all I do is I just simplify this. So it's 2 plus, when you distribute, you get, 3n minus 3. And then when you add like terms, you have a sub n equals 3n minus 1. So that is your formula. The other way of coming up with it is, I think this might even be easier. You actually know what the sequence is. If the first term is 2 and your common difference is 3, you keep going up by 3. You keep adding 3. So 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11, and so on. And then you could see your common difference is 3, so you know it's going to be 3n. And then here's the trick. If you go the other way, if you take away 3 from 2, you get negative 1, which gives you the same thing as this. I don't care which way you do it, as long as you get the right formula. Okay, number 2, we want to find the 52nd term in this sequence. Well, what you should notice right away is, for a lot of these sequences is, all right, what's the common difference? Well, you can see if you go to negative 3 to 4 to 11, you're going up by 7. So I'm going to say D is 7. Now, you could keep adding 7 to it till you get the 52nd term, but that's just going to take too long. All right? This is where the formula really comes in handy. Now, if I want to find the 52nd term, I'm going to let n equal 52 for this formula. So I'm going to put a sub 52. The good thing is I have the first term, so I'm going to put a sub 1 plus, and then I know d is 7, so I'm going to have 7. Now remember, this is the n minus 1, so n is 52, so it's 52 minus 1. So I'm just using that formula I derived. So when I plug these in, a sub 1 is, this is negative 3. And then I have 7 times 51. And then you could just plug this in your calculator, and if you plug it in, if you did negative 3 plus 7 times 51, it gives you 354. So that is the 52nd term in the sequence. A lot easier using the formula than just keep adding 7 to it. Could you do it? Yeah, you could do it, but it's going to take you forever. Just use the formula. Number 3 is the same type of problem. You want to find the 68th term. First thing you want to identify, what is the common difference? Now this, it goes down. So right away, I know my difference is going to be negative. And then I can see I have to keep subtracting 9. 16 minus 9 is 7. 7 minus 9 is negative 2. So my difference is negative 9. So I'm going to do the same exact thing. When I use the formula, I let n equal 68. Because that's the numbered term in the sequence that I want to find. So I just want to set it up first. I'm going to have a sub 68. I have the first term, so I want to put a sub 1 plus. The difference is negative 9, so I'm going to put negative 9 times. And this is, n is 68, so it's 68 minus 1. Okay, then I just substitute the 16 right in there for the a sub 1. So it's 16 plus negative 9 times 67. Real simple. Put it right into your calculator. When you put it into your calculator, you're going to get negative 587. That is the 68th term in the sequence. All right, let's go to the next page. Okay, on this page right here, we're going to skip number 4. And what I'm going to do, I'm just going to write this up here. You don't have the first term. This is where you have to use the variation of the formula, which I'm going to explain into more detail in class. It's a little bit more difficult, so I like going over that in class rather than putting it on the video. So number 4 we'll do in class tomorrow. Let's just do one more. Let's do number 5, and then that'll be it. Okay, 31st term of sequence is 197. Common difference is 10. We want to find a sub 1, right? We want to find the first term. So it's a little bit different. A lot of the other ones, we were given the first term. Here, I want to find the first term. Now, if it tells me, this is what it tells me. It tells me a sub 31, that's the 31st term, is 197, and the common difference is 10. Now, if the common difference is 10, you know like a sub 32 would be 207. You would add 10. Well, one thing you could do is, if you go the other way, you could keep subtracting 10 till you get to the first term. Again, don't do that. It's going to take you too long. Use the formula that we derived. Now, if I use the formula that I derived, I'm going to let n equals 31 because that's the number term in the sequence that I know. So if I use that, I'm going to let n equals 31 in the formula. I'm going to have a sub 31 equals a sub 1 plus, I'm going to have d, which I know is 10, and then I have it times n is 31, so I have it 31 minus 1. Now, this 197, I'm going to plug that in for a sub 31. I don't know what a sub 1 is, so that's what I want to solve for. I know what d is. D is this, it's 10. So it's 10 times, what is it, 30? So then we have 197 equals a sub 1 plus 10 times 30 is 300. And then all you do is subtract 300 from both sides. And it's going to give you the first term, a sub 1. So when you subtract 300, you get negative 103. So that is the first term in the sequence. Okay, so really the pattern, it's very easy. You can pick it out right away. You either keep adding the same number or subtracting the same number to get the next term. The formula will help you out. Do you have to use this formula that we derived every time? No. I don't care how you get the answer, just as long as you get the answer. Some cases, it's easier to use the formula. Some cases, it's not. All right, so number 4, we'll definitely go over this in class. We'll use the variation, and we'll also do this. This is going to be another formula that I'm going to give to you, where we look at a sequence, an arithmetic sequence, and we add all the numbers. So that's why it's called a series.